Hello, today I'm going to explain what sets are. So, a set is an unordered collection of elements. What that means is the following. Suppose I have a set made up of strings, and those are my strings. I do not care about order. So, to understand this, I think it's best to compare it with an array, whereby in an array we typically have an order. We typically have for example, the number 6 at index 0, or since we're dealing with strings, maybe I could put strings in there. So suppose I have the word 2. So if I'm comparing with an array, the array is an ordered collection of elements because 2 has index 0, sorry. That has index 1, beautiful, index 2, and sky index 3. Whereas in a set, the way things are stored um, is unordered, so we don't care which comes first. There is no order, they're all kind of equally stored, if you will. And another important distinction is that sets do not have any duplicates, meaning I cannot have two thas here, whereas in an array, I can have here another that at index 4. Okay. And now you might be asking why the transition if we have already a structure that's already working, so why the hassle, why move to sets? How are they important? And they're important because they're very efficient. So when I check whether there's a that in this set, I can get it um, in a complexity that's as low as order 1, so in constant time, whereas in an array I'll have to loop through the entire array to check whether it contains a the, and as we know it's order n. Oh shoot. So this is one of the distinguishing factors. Now let's go here and have a new file where we'll test. So we're gonna test the sets. I'm gonna make a new set here, so set. And I'm gonna add stuff to it. Words dot add the words dot add hello, words dot add beautiful, and then that's enough. Let me try to print this set. So words, so I'm gonna print this as system dot out dot println sets, and let's see what will happen. Oh, the sets is called words, so okay. CD desktop. I think I have a syntax error. Oh, it's that. Okay. That's weird. I suspect it's because we didn't add this import statement. I hope it works now. Yep, it does. Just need to remove this C. And my set is printed. So, yep, it works. Now, another very important thing about sets is that sets are an interface, meaning we can have this same idea of a set implemented in two different ways. One is a hash set, meaning that we're implementing this concept of a set using a hash table, and another is a tree set, meaning we're implementing this idea of a set using a tree, a binary tree. And why do we do this? Because each has its own advantages. So if you see here, I implemented my set using a hash table, so it's called a hash set. I have to specify here how I want this set to be implemented. So why would I use one over the other? A hash set is implemented using a hash table, and most operations of a hash table are of order 1. Meaning add, remove, and even check if it contains. Whereas a tree set is implemented as a binary tree, and all okay, and why would I want it to be implemented as a binary tree? When would I use a tree set? Mainly I would use a tree set if I want my set to be sorted. In this case, all the operations that I can perform in a set, which are add, remove, and checking if it contains a certain element, will be of order log n, because I want to keep this tree sorted. Suppose I already have a list. Um, going to call it characters equals new array list. And I'm going to add a few characters here. So let's suppose I have Cinderella, um, Rapunzel, and Elsa. So those are the three characters that I have. All right. So if I want to put this list in a set because I want to see whether a certain word is present in a book, so there's no need to loop over every element in the list. You can automatically just put the list's name between those params and they'll be added to the set implicitly. And of course I could keep adding stuff. Those are added after these are added to this set. So now if I print my set, I'm gonna have all those six words. So let's do this. Okay, let's look. Here I have the beautiful Elsa, Rapunzel, Hello, Cinderella. Okay, now let me make this a tree set. And now I'm gonna repeat this exercise. So, compiling. Oh, okay, so I need to import the tree set here. I don't know why it's not doing the imports automatically. So let's import it. Okay. Now compiling again, running the bytecode, and I have Cinderella, Elsa, Rapunzel, then beautiful, hello, there. And notice that I have them in the order that I put them in. Oh no, actually I have them sorted. But the capital letters are always considered first when sorting something. So let me reprint. Okay, let me reprint. See how my set is sorted, and this is because I used a tree set. So whenever I want to print something in a sorted way and I care about order, even though sets do not have order, they're an unordered list of elements. I know internally that they're implemented it as a tree map. Sorry, as a binary search tree, and that binary search tree remains sorted. So whenever it prints them in a sorted manner. So if that's something that I care about, then I should perhaps use a tree set over a hash set. Although the hash set is better in its runtime, it gives me uh, a constant order time for almost all. Actually, all, yeah, the contains, the add, the remove operations, whereas the hash set gives me an order log n. So here comes the trade-off between the two things, and which one you might want to use. Now let's see if this set contains something. So I want to print whether it contains a certain element or not. So print line, my set is called words. So words dot contains Cruella. And let's test if it contains Rapunzel. Okay, so we're gonna do this just right now. And what I expected to print is false, then true. Which is exactly what it printed. False, it does not contain Cruella, and true, it does contain Rapunzel. So this is the first method. But now suppose I wanna, that's the remove method, so I'm gonna remove Rapunzel now. Sorry, I'm gonna remove it. So words dot remove Rapunzel. And now I'm gonna print this statement to test whether my set contains Rapunzel. And it does not. My set no longer contains Rapunzel. Now, after I've removed Rapunzel, I want to test how many elements I have um, inside my set. So let's go ahead and do that. And I expect to find, I believe, 5 elements. Oops. Why do I have an error? Oh, I'm leaving the words dot contains here. I believe this is the problem. Words dot is empty and there's an extra parent. Okay, this should work. So first let me check if it's empty, then I want to check its size. Alright. So it's not empty and the size is 5 as I've anticipated. Okay. Now, if I had a set that was full of numbers, I can use the toString method and return a string. Let's test a set that has full numbers. Okay, I want to use the same set. So I'm gonna clear everything inside this set. So let's use the clear methods here. And words dot clear. So now if I print out words, I expect to find an empty set. Exactly, this is why I have nothing inside the set. So now let's add numbers to this set. Oh, I forgot that I can't do that because it's a string set. My bad, that's a very silly mistake. Okay, so suppose I want to clear it and make a new set then. So set integer, and I'm gonna call it integers is a new hash set. And let's start adding a few numbers in there. So integers.add 9 and gonna make this an 11, 14, and one more. Let's make this an 8. All right, and now I want to print it. So I'm gonna print it again here. But it's not called words, it's called integers. So let's print integers. And let's see the difference between printing this and printing integers dot to string. All right. So it prints both of them. But I would particularly use this method if I wanted to change this to a string for a reason or another. Now suppose I want to add a new word. Oh, I can't do that. Okay, so new word. And this new word is integers dot to spring. And then I want an array list called new words. And to new words, I'm gonna add a few strings. So add, I'm gonna add a new word, right? And then I'm gonna add taxi. Then I'm gonna add bro. So that's my new list that has 3 words. And I want to add it to words. So words dot add all. I want to add this entire collection that I'm gonna call new, that I've already called actually new words. And now I want to print words dot oh, I'm gonna print words, yes. Okay, now remember that words has already cleared everything at this point, so I expect it only to print those 3 words, which are the numbers turned to string. this be the issue? So see, it prompted as expected, although I'm not sure why we have an unchecked or unsafe operation. I'm not sure what operation that is, but it worked as we expected. Like it's warning, but it did compile correctly. Okay. Okay, so here I just cleaned the code a bit. I made an array list called characters, and I had Cinderella Rapunzel. And I added all the elements in this array to. So now that it has everything, if I check here whether this set contains everything that's in the array list, it should give me true, right? My set is called Disney dot contains all, and the collection is characters. Yep. And yep, it's true. Okay, so now I've covered these two methods. Okay, now let's check the equals. Okay, so I'm gonna make a new set and I'm gonna call it I don't know what to call it. Jeez. Cartoon. I'm gonna call it cartoon. Okay, and it's a new hash set. Let's add a few things to cartoon. I'm gonna add Spider-Man. Gonna add Cinderella. Hopefully I spelled it the same as above. Okay, yep, I did. And then cartoon.add what cartoons do we still have? Okay, let's me add Ben 10. Okay. Now I want to see if those two sets are equal. Okay. So in order to do that, I'll print the following. So sys.out.println, and okay, the first set is called Disney dot equals cartoon. Yep. Now let's check if they're equal. It's supposed to give me false because they're not equal. They only have Rapunzel in common. And therefore, I got the right answer, false. True is if it contains all. It's from the above previous exercise. So yes, I did get the right answer. Now iterator will be discussing it later. Remove all will happen if I want to empty it. But let's discuss retain all. That's a very interesting thing. Okay, retain all is gonna give me the intersection between a set and a given collection. So let me do the following. No, not Disney. The second one is called cartoon. Okay, so I want to check cartoon dot retain all, and here I'm gonna put Disney. So this is supposed to return only the common things between Disney and cartoon. Okay, and then I'm gonna print Disney, and I'm gonna print cartoon to see if it changes the entire set. So let's see. I'm gonna comment out these because we don't need them anymore. Okay. So, Rapunzel, Elsa, Cinderella. Okay. I don't understand what just happened. No, it acted correctly because cartoon used to have Cinderella, Spider-Man, and Ben 10s, and when I applied retain all, what happened is that what's common only remained. But of course um the collection that I pass as a parameter does not change. Only my current set changes. That's what I guess this does. And okay, here two returns if the method executed correctly, I believe. So we're done with retain all. I can turn this into an array if I want to. So let's say cartoon. Okay, so say list string, and I'm gonna call it cartoon, but this time with double T and double O, equals new array list. Oh no, it's not equals new array list. It's equal to cartoon dot to array. Yep. Oh, okay. And you know what? This should be a string array. Okay. And now let me print out. I got an error over there, so I still have. Okay, when I added this inside the to array, it worked. Let's see. Let me print out. Cartoon. I don't expect it to print out because now it's an array and no longer a set. So I expect it not to print out correctly. I expect it to print out the memory location. Oh, it did print it out correctly. Does this mean that cartoon room? Okay, here it did print the location in memory. Does that mean that cartoon remains a set? And I believe yes, because I can't write cartoon.contains, but I can write cartoon.contains, meaning that it's still a set even after I ran this method. It doesn't change. Oh, because I did new. Okay. How about now? Still, it didn't change it to an array. So what I deduce is that it returns an array of the elements in the set, but keeps the set. It doesn't change the set. Okay, so this is it for this part of the video. I'll